Alright guys, today's going to be pretty short because there's only like 2 real slides, but on your notes it's like the next 3 pages. So we had finished this question last class. Now we're throwing in some trig functions. So there's a slightly different format when you have something involving trig functions we haven't learned yet. So one thing to recognize is that you can always turn your trig functions into something you know of and then derive what the integral is. So like, for example, tangent of dx, right? We know that that's the same thing as the integral of sine of x dx over cosine of x, right? So you won't have to do this again once I show you the process, but if you're ever in a bind and you don't know how to find the integral of a trig function that we haven't learned yet, this is how you can do it. You can turn it into a trig function we do know. You can then use u substitution, so u would be cosine of x, and then du is negative sine of x dx. Okay, so that way just remember we're taking the derivative here to get that. But then that means you're integrating 1 over u du. Notice there's a negative, so we have to pull that out, okay, because it's not in the original. So then if I take the integral of that, I get negative ln of u, absolute value, plus c. So negative ln of cosine of x plus c. And if you move on to the next page, now, because we're distance learning, you guys aren't going to have to memorize these, which is super nice. You'll see that your integral of tangent of x dx is always this. So this is all of your trig functions. We already know the first 2, right? You know the integral of sine is negative cosine. You know the integral of cosine is sine, because just a reminder of how that works. The derivative of cosine is negative sine, hence why we can go backwards. And the derivative of sine is cosine. So we're going to get into using more of these in the next 2 problems, but I want to remind you this is the one that we just did. So you won't actually have to show how you got the derivative or the integral. Now you just know it. You just have it handy, okay? We haven't taken the integral of these before. I know it seems weird because we've taken the integral of like everything else, but if you need to show how that works, you can always turn these into other properties, then take the integral of them if you want to see how they actually work out. I'm not going to do more of the proofs with you because we don't got time for that. So we're going to move on to evaluating the identities here. So just a heads up, these are definite integrals, so we're going to integrate and then plug in the values like we're used to doing. This is going to require u substitution for the first one, so just want to remind you, u, much easier to use the denominator here, is going to be 1 minus 4 cosine of x, and that means that du is going to be 4 sine of x. Remember, we're taking the derivative here, so if you're having trouble going back and forth, feel free to have your derivatives of trig functions handy as well, because your derivative of cosine is negative sine, hence why this turned into a positive 4 sine of x. Okay, so the nice thing about this is that literally just becomes the integral of 0 to pi over 4, or pi over 3, I mean. Something that I know some of us are going to do is think that you've already taken the derivative of this, but you need to be careful. You took the derivative of u, and you want to integrate this function now. So it's 1 over u du. Okay, the integral of 1 over u, as per usual, is going to be ln absolute value of u. We don't need to worry about the plus c because we're integrating between the 2 points. Make sure you plug u back in. So it's ln absolute value of 1 minus 4 cosine of x between 0 and pi over 3. And just a reminder again of how to do that. You plug in the pi over 3. So ln of 1 minus 4 cosine of pi over 3 minus, subtract, right? So ln of 1 minus 4 cosine of 0. And yes, you can plug that into your graphing calculator if you want to. If you do it out by hand, because the cosine of pi over 3 is a half, and then the cosine of 0 is 1, you end up with negative ln of 3, which is a nicer way to write that, but then you could say it's approximately negative 1.099. And because you are in radians, make sure your calculator's in radian mode because you're plugging in radians there, okay? The next one, I want you to try it. Just a reminder that you are going to have to use substitution here. It doesn't involve trig, which is really nice, but it looks a lot like one of the questions we did in the first section of the notes. So see if you can look back. Remember, it is a definite integral, so you're going from 3 to 4. So integrate first, then plug in the numbers, pause the video, try it out on your own. This is the last question we're doing today. So like I said, pretty quick. All right, just wanted to give you a reminder of what u is going to be here if you're stuck. It's going to be ln of x because then the derivative is 1 over x dx. So that way you can see 1 over x within there, okay? I pulled the 5 out as well just because it'll be easier for you. But then when you integrate, you get 5 u squared over 2 between 3 and 4, which means it's really 5 times ln of x squared over 2. You can write it like that instead if that's easier. Between 3 and 4. And then when you plug it into your calculator, or you can see how it looks by hand, first it's 5 ln of 4 all squared over 2 minus 5 over 2 ln of 0 squared. And just a reminder that the ln of, that's not a 0, that's a 3. Sorry, that's the ln of 3. Can't read my own handwriting. Okay, so then if you plug that all into your graphing calculator, you get approximately 1.787. Okay, so hopefully that is what you got. So tomorrow is going to be our last set of these 5.2 notes. And just a reminder that then we are going to do a review on Friday with then a little extra class review that's going to be optional. And we have a test on Tuesday on 5152 next week. So just a heads up about what's coming up. I hope you have a wonderful rest of your day, but please join my office hours if you were struggling through any of that.